Let G be a group of order 7. So this is given, order of group is 7 and 7 is a prime number and group of prime number is cyclic. So it is commutative also. Cyclicity implies commutativity. So group is abelian also. Now a mapping phi is defined as phi x equals to x raised to the power 4 where x is coming from the group. Option A, B, C is saying, or we have to check 1, 1, onto and homomorphism. First we will it is easy to check homomorphism. Homomorphism we check like this: phi of xy equals to phi of x into phi of y. Here operation may be different. It may be star and this may be small size circle. So operation may be different, but for convenience I used multiplication. So there is no confusion. So phi of xy equals to xy raised to the power 4 and group is abelian. So we can use power rule. Power rule says x raised to the power n, because of power is 4. So you can use 4, y raised to the power 4 and this one can be written as phi of x into phi of y. So mapping phi is homomorphism. Now option C discarded. Because group is cyclic, it means group is generated by some element say x. So if x is generator, then order of generator and order of group is same. We know this property. And equals to 7. So what does it mean? X raised to the power 7 equals to identity. Before this, no power give you identity. Now try to evaluate some output for input. So phi x. Phi x equals to x raised to the power 4. Phi x square equals to x square power 4 and this one equals to x. You can use like this: x raised to the power 8 equals to x raised to the power 7 into x, and x raised to the power 7 is identity. So finally x. Now you can use or find other powers also. X cube equals to x raised to the power 5. Phi of x raised to the power 4 equals to x square, and try to find other powers. I am writing all input and output simultaneously. X raised to the power 4, x square equals to x, phi of x cube. I already calculated, that's why time is not, I am not taking time, otherwise it may take some times. So phi x raised to the power 4 equals to x square, phi of x raised to the power 5 equals to x raised to the power 6, and phi of x raised to the power 6 equals to x cube, and phi of x raised to the power 7 is identity. And we know that homomorphism send identity to identity, so it will identity. So you can see, you can check for each input. For each input, there is a unique output. For each input, there is a unique output. So mapping is 1, 1 and onto. 1, 1 onto and homomorphism. It means you can say isomorphism. So which one option is best one? Option D is right one.